just going to solve some IGCSE exam questions on inequalities. First one, solve 5x minus 6 is greater than 2. So adding 6 to both sides gives 5x is greater than 8, and dividing both sides by 5 gives x is greater than 8 over 5, which would be fine as the final answer. If you wanted to, you could write 8 over 5 as 1.6 and say that that's x is greater than 1.6. Remember, we manipulated inequalities just like equations in terms of most of the operations, but if we multiply or divide by a negative number, we're going to change the sign of the inequality. And also we need to think a bit more if we do anything like a complicated, more complicated operations like squaring or other things. But if we just do multiplications, divisions, additions, subtractions, they work like ordinary equations, except for when we multiply or divide by a negative number, so that's fine. X is greater than or equal to 1.6 satisfies that inequality. Okay, next question. Show by shading on the grid the region which satisfies these inequalities. So we want 1 is less than or equal to x is less than or equal to 3, and minus 4 is less than or equal to y is less than or equal to minus 2. So this one first, x is between 1 and 3, so that's all the values of x between 1 and 3, and y can be anything for this inequality. Okay, so I'm going to, now it's less than or equal to sign, so I'm going to use a solid line to indicate that, and so that's the lines x equals 1 and x equals 3, and if I get rid of everything outside of here, I'm going to show that that's the bit that I don't want. Of course, you could do it the other way around. I'm just going to make it really clear at the end which area I'm interested in. And now we want y is between minus 2 and minus 4, and so there's y is minus 2 and minus 4. If we get rid of everything outside of there, then this is the region that I want, R. And it's worth just saying that all of the lines are included in R. So what I mean is that these outside boundaries are included. If it was strictly less than here, like if it was 1 is less than x is less than 3, I would say that some of these lines might be excluded, and if it wasn't, if it was only some of them included and excluded, I'd have to make that clear as well. But here's the region we're looking for, and all the lines are included in this case. Okay, solve the inequality 4x plus 5 is less than or equal to 21. So subtracting 5 from both sides gives 4x is less than or equal to 16. So x is less than or equal to 4. And it says here, write down all the values of n which satisfy 4n plus 5 is less than or equal to 21, where n is a positive integer. So integer means a whole number, and positive means bigger than 0. So the first one there is 1, the next one will be 2, then 3, 4 is included because it's less than or equal to, and that's it. So they're all the positive integers which satisfy n is 4n plus 5 is less than or equal to 21. Notice 0 is not included in there, it's not a positive integer, it's neither positive nor negative. Looking at the next question, I want to show by shading on the grid the region which satisfies all three of these inequalities. X is greater than or equal to 1, y is greater than or equal to x, and x plus 2y is less than or equal to 6. So I'm just going to start by drawing the lines that are going to be the boundaries here. So that will be x equals 1, y equals x, and x plus 2y equals 6. So you do need to be reasonably good at your straight line graphs to do these. So x equals 1 here is the line like this. You should use a ruler, of course, for all of these. Y equals x. Y coordinate is just equal to the x coordinate. Hopefully you know that that looks roughly like that. Again, a bit straighter than I've drawn it. And the last one, x plus 2y equals 6. If you want to rearrange that into the form y equals mx plus c, we've got 2y equals 6 minus x. So y equals 3 minus 1 half x. So it's got y-intercept 3 and gradient minus 1 half. So every time x goes up 2, y goes down 1. So it's going to go through all of these points here, and that one there. So again, it's going to look something like that. And now we just need to decide which of the regions it is that we're looking at. So I want x is greater than or equal to 1, so I want things to the right of this line x equals 1, so I can get rid of all of that part. I want things where y is greater than or equal to x, so I want things that are above the line y equals x, because for a particular point here, this is where y equals x, so if I make y bigger without changing x, that'll be where y is bigger than x. I want to get rid of all these ones down here where y is less than x. And for the last one, again, this is a line where y equals 3 minus a half x, or x plus 2y is less than or equal to 6. That's what we're looking at in the inequality though. So let's just test a point for this one. So for example, you know that where it's less than or equal to 6 will either be everything below the line or everything above the line. So let's take an easy point. So look at this point here, 0, 0. That's below the line, and that's got 0 plus 2 times 0. That's 0. That's less than or equal to 6. So we do want the things that are below the line here, and we want to get rid of all the stuff that's above the line here. And this is the region R then, which satisfies all three of the inequalities. And again, you might just say, to make this clear, that the lines are included because they're all less than or equal to or greater than or equal to inequalities rather than strict ones. It's slightly harder inequalities questions here where it's not just linear one. We've got a squared term in here. We want to say, okay, so what values is x squared less than 4 for? Okay, so obviously, you might just say, okay, we'll square it both sides and get x is less than 2. But if you think about negative values, yes, it works up to a point. X is 0 works. But then what about negative ones? X is minus 1. Minus 1 squared is 1. That's fine. Minus 2 squared is 4. But if I go down below minus 2, something like minus 3 squared is 9. So that's actually not less than or equal to 4 anymore. So we need to cut this off at minus 2. So the solution to this inequality is minus 2 less than or equal to x less than or equal to 2. And again, it's less than or equal to because this one's less than or equal to. So showing this on the number line, well, I'm going to say that's everything between minus 2 and plus 2. And I'm using these solid dots on the end to show that it includes those values. If you remember, if it doesn't include the values, you'd use an open circle, like that. So that one, if it had been to the same points, would have been minus 2, strictly less than x, strictly less than 2, like that. Okay, but we want to include those endpoints. So that's that. Similarly, another one here. So where's y squared less than 9? Well, it's exactly the same idea. It's going to be between minus 3 is less than x. It's less than 9, but it's a strict inequality here. And if I was going to put that on the number line, then that would be between minus 3 and 3. And it would be all of those values in here. The only other way that could go is if it was to say, what about where is, if it had said where is y squared, bigger than 16, say, well, that's exactly the sort of opposite region. It's all the values beyond 4 and less than minus 4. So that will be y is bigger than 4 and y is less than minus 4. Again, if I wanted to put that on a number line, I'd start at minus 4 and it would go downwards, and start at plus 4 and go upwards like that. So it's anything smaller than minus 4 and anything bigger than plus 4. The square is bigger than 16. We use these arrows to say it goes on forever in that direction. Okay, so there we go. That was a series of questions about inequalities, linear inequalities, shading regions, and then finally a couple of quadratic.